Welcome back. In this video, we are given that f of x is the integral between 1 and x of the square root of 1 plus t cubed dt. We want to find the derivative of the inverse function of this f at 0. Here, we don't know the inverse function. We don't have an expression for that. But we're going to use the derivative of the inverse with the function itself to find the value that we need. But before that, we want to make sure that the f inverse exists. So this is a key here. But since this one is increasing, we're just going to prove that f is injective. Okay? So if we can prove that f is injective, we are done. Okay? So how can we prove first that f is injective? So so here showing that f is injective. Okay, so this is the aim. So we wanna let x and y be from this interval 1 plus infinity. So let x and y in this interval. So x and y, both of them bigger than 1, and with the condition that f of x is f of y. So here we need to show that x is y. So if we do that, we can find the inverse. We can use the inverse of the function. So here f of x is f of y. So f is continuous. This one here, sorry, not f. First, the square root of 1 plus t cubed is continuous, defined everywhere, and therefore f is continuous. Okay? So it's continuous, therefore it's differentiable here because it's defined by this integral. Therefore, we can differentiate. So according to the fundamental theorem of calculus, we have f of x is f of y. Okay, so this is our assumption. We want to prove that x is y. So here, this means that the integral between 1 and x of 1 plus t cubed dt is equal to 1, the integral between 1 and y of 1 plus t cubed dt. Okay, we can either differentiate, as we said earlier, we can differentiate or we can make the difference. But we gotta differentiate, we get, according to the fundamental theorem of calculus, we get 1 plus x cubed is the square root of 1 plus y cubed. So I said the square root of 1 plus x cubed is equal to 1 to the square root of 1 plus y cubed. So raising everything to the square, because here everything is positive, so we can raise everything. So we have 1 plus x cubed is 1 plus y cubed. So this means that x cubed is y cubed, and this means that x minus y times x squared plus xy plus y squared is 0. This quantity here is never 0. Therefore, x is y. So we can prove this one using the discriminant that this is never 0. So here we have x is y, and therefore here f is injective. So this is the aim, and we have reached that goal that we need. So x is y. X is y means that f is injective. Now, note that f of 1 is what? So here it's the integral between 1 and 1. So here, according to the definition of f, when we plug 1 here, we're gonna get 0. Okay, so the integral between 1 and 1, it's 0. So here, so this is just the integral. Okay, so this is 0. And since f is injective and increasing, f inverse exists, and therefore we have f inverse of 0 is just 1. Why do we need this? Okay, because now we can find the derivative of the inverse function at 0. Okay, so we know that f inverse prime at 0 is 1 over f prime f inverse of 0. Okay, and what's the derivative of f? According to the fundamental theorem of calculus, this is just the square root of 1 plus x cubed. So it's going to be 1 over the square root of 1 plus f inverse of 0 cubed. So here, but this is just 1, so we have 1 over the square root of 1 plus 1 cubed, which is 1 over the square root of 2. So this is the answer to this question. So therefore, we found that this is just 1 over square root of 2. Okay? So we use the fundamental theorem of calculus to get the derivative, and also this part that f is injective. F is being injective is telling us that this is the only one. Okay, so f we can have the inverse function. Okay, because if it's not, we can't have maybe f of 0, maybe not 1, maybe other things. Okay, so this is the key idea that we needed here. Okay, so that's the answer for this question. If you see any errors or mistakes, please let me know. Thank you.